Hello everyone, my name is Yi, and today our group will talk about our Phase 2 project. It's about FIFA 2026. We have like seven tables here and three relations here. The tables are country, position, legend, club, player, additional info, and rankings. Also, three relations here: players club, players country, and players position. For the country, we use the nationality ID as the key. For the position, we use the position code as the primary key. For the legend, we use the legend ID as the primary key. For the club, we use the club team ID as the primary key. And for the player additional info and the ratings, we use the player's ID as the primary key. We also add an index functions to make it work more efficiently. So like, let me just run it. And we can check the tables. Yeah, we have 10 tables now here, and check the columns. It will show what exactly we have now. And then we cancel the schemas in there. Here. Yeah, it will show you all of the tables are public and their names and their types. And then behavior will talk about how we enter the data into the database.
Hello everyone, I'll show you my PG admin. Uh, so how we entered the data, first we ran a Python script to distribute data into 10 separate tables that we needed. Before it was all clustered into one CSV file. I can show you I don't have currently any data loaded right now. And we use this SQL script to load every data into our tables here. When I run this, it will show it copied 37,544 data into those 10 columns. And let's try and see if this works. We can see the first 10 club names that pop up, and we can also test it with player. Here are the 10 players from the CSV file, top 10. And I'll send it over to Naimish. He'll tell you more about our SQL queries.
Yeah, thanks, Bhavya. So now I'll demonstrate the SQL queries which we have implemented. So the first one is a select. So this is for player search. So the query finds the top 10 players in the database and sorts them by their overall rating, right? And we are selecting the name, overall rating, position, and just sorting by overall rating in descending order. So here is the script. And yeah, as you can see, the results are right here. It shows the highest rated player in our database, right? And for the second SQL query, this one implements comparison for strikers. It just selects top five players whose positions include ST or striker. And I'm using the like operator to match any positions containing that, right? So a player can have multiple positions as well. So here is the query. It shows top five strikers sorted by their rating, and the user can compare them in any order. The third query that I will show is an insert query. But first, I would like to show that, okay, there's no player with the ID this 99999. And here is the insert queries, right? So we are inserting player 99999 with the name J Doe, a central midfielder with rating 72. And the subsequent queries also insert his ratings and the additional info that's needed. And I've added a final select query which verifies that the player was added. So let's run that. Here you can see the player is added, right? With his name, his club name, and every info. And now I'll just pass it on to Juhil and he'll talk about the rest of the things.
Okay, so the query for update, modify player rating. Player ratings change throughout the season based on performance. Here I am updating player 9999 specific skill rating. The ratings table is passing improves to 75, dribbling to 78, and pace to 76. The where clause ensures we only modify this specific player. Below that is the verification query to confirm the changes. Let me just execute this. Perfect. The result shows the 9999 now has the update rating passing 75, dribbling 78, and pace 76. This is how the database stays current as player develop throughout the season. Moving on to the next query, delete. Remove player. When a player retires, we remove them using a delete statement. Here, I'm deleting a player 999 from the player table. Below is a query to check if it's there still exists. After I execute the query, look at the result. The table is empty for this player, but we only wrote one delete statement targeting the player table. The ratings were automatically deleted because of cascade constraint. When we design our foreign keys, we specified on delete cascade, meaning when a player is deleted, all related records in ratings, additional info, player club, player country, and player position are automatically removed. One delete statement clean up the data across five tables. This is the referential integrity in action. No operand data, no manual cleanup required. This cascade behavior is fundamental feature of well-designed relational database. And conclusion, if you want to summarize, we successfully implemented our 2026 FIFA player management system for phase 2. We transform our phase 1 EI diagram into a normalized PostgreSQL schema with 10 tables, populated it with over 18,000 real player records, and demonstrated 5 SQL queries. Implementing our core features, player search, comparison, insertion, updates, and deletion with cascade cleanup. Our database properly handles relationships using appropriate data types and maintains referential integrity throughout through foreign key constants. Thank you for watching.